The question asks that what about R2? We are actually not focused on the R2 or R4 because no one is actually requesting R2 or R4. The two process P1 and P2, they are already have got R2. So these two processes are actually not interested in R2. So whenever P1 and P2 is finished, R2 will also be released. Okay. And one more thing that another one of you asked, that resources don't request process. Okay. Printer will not request that, hey, I want to do that work. Instead of, the work will go to the printer and say, okay, do that work. That's how it works. Okay. It's not like the printer will say, please come to me, P1 or P2. That's not how things are done. Okay. Process go to the resources, like please help me to do the work, please help me to print, please help me to take input. Okay, and this is how it goes. So when we have to look for dependent processes, and resources are not here, R2 is been allocated already. Okay, no one is requesting R2, so that's why we didn't actually focus about that too. Now, any other questions?
No, sir.
Now what you have to do is that if you have understood this one, okay, you have to actually now you have to find out this one. So here is now the time is 12:43. Okay, and you have till like 1:15, that is 1:15. So find out the answer of this two, whether there will be any deadlock or not. You see the answer is already given. If you look closely, the question is that, is there any deadlock here? Is there any deadlock here? So you see, first of all, the answer is this resource allocation graph will have a deadlock. That means at some point it will get stuck, and this one, the resource allocation graph, will have no deadlock. Okay, so let me I have explained this one to you. So let's see if you can understand this too as well. Okay, we have up till 1:15, so I think I can do that. So first of all, let's go start with this one. So here, first of all, let's start with P1. So this is the same picture. If you see, this is the same picture as this one, just one small change. Okay, what is that small change? The change is that now what we have done, we have assigned this P3, this R2. That means P3 is waiting for R2, and this actually changes everything. Okay, so previously P3 was an independent process. That means P3 actually could do its work. It didn't have to wait for anyone. So at certain point, maybe after 1 hour or 2 hour or 3 hour, P3 will be finished. Okay, but now you see the problem is P3 is waiting for R2. Okay, and R2 is already assigned to P1 and P2. So let's assume R2 is a printer and it has two printers. So both printers are assigned to P1 and P2. So P3 is waiting for these printers who are actually assigned to P1 and P2. Now the problem is, as P3 will not get R2, P3 will not be finished. Okay, and as P3 will not be finished, okay, R3 will not be released. So as R3 will not be released, okay, the problem, it will happen that P2 will not be resumed, or P2 cannot do its work. And as long as P2 cannot do its work, it cannot release this resource, that is R2. Okay, because to release this resource, P2 has to be completed. Same goes for P1. Okay, so you see the problem here now. Just by changing one simple condition, I have created a circular wait. In that wait, P3 is waiting for R2, but R2 is already assigned to P1 and P2. And P1 and P2 are waiting for R1 and R3, which out of R3 is already assigned to P3. So basically, the example that we have seen here is all over this again. Okay, P3 is waiting for R2. R2 is actually waiting for again R3. Okay, R3 is actually taken by P3. So P3 will not release R3 as long as it have it. So this is the problem we have. Okay, in this one. So there will be a deadlock. The answer is yes, there will be a deadlock. Let's go for another one here. So I hope you understood this one. Now, in this one, you see R1 let's start with P1. P1 is allocated, uh, P1 is requesting R1 and P1 is already allocated R2. So P1 is a dependent process. And in this one, P2 have allocated R1. Okay, so P2 is actually not a dependent process. Okay, P2 is not waiting for any other resources. Then we have P3. P3 is waiting for R2 and P3 have been assigned R1. And then we have this P4, another so this is a dependent process. Okay, and then we have P4. P4 is actually not waiting for anyone. So in this case, what will happen, even though initially it seems like that P1 is waiting for uh, R1, R1 is taken by two other processes. So it's, and P3 is waiting for R2, R2 is taken by P1. So it initially seems like there's a deadlock here. What is the deadlock? Because P1 is waiting for P3, okay, and P3 is waiting for again P1. You see the problem? P1 is waiting for R1, okay, and R1 will be released when P3 is done. But P3 will not be done until R2 is free, and R2 is taken by P1. So basically, initially P1 thinks that I'm waiting for P3, and P3 thinks I'm waiting for P1 to finish. Okay, so this is the first initially it seems like there will be deadlock, but the answer is there will be no deadlock. Why? The independent process actually comes to our rescue. So you see P2 and P4, these two processes will be finished at certain point of time. That's for sure. Okay, maybe it will take 1 hour, 20 hour. Okay, so when the P2 is finished, it will release R1. Okay, so R1 will be free and P1 can actually take R1. And when it can take R1, okay, the released printer by P2, okay, it can actually finish this work, okay, and it can release R2. And when it will release R2, okay, it can actually take, P3 can take R2 and finish this work. Or another thing that can happen, P4, okay, P4 actually can be finished, and when P4 is finished, P3 will actually take the slot left by P4. Okay, so P3, let's assume P3 will take this slot. Okay, and when P3 will take this slot, it will also finish and it will release this one. Okay, this slot. And when it will release this one, P1 can do its work. So in this one, even though initially it seems like there's a deadlock, but there will be no deadlock. So in this way, you can actually identify whether there's a deadlock using just these two simple steps. First of all, look for independent process. Okay, and you see that whether that independent process allocates or distributes any of the resources you have. Okay, so if there's an independent process, okay, it will get finished at certain point and then you can move on to the next. But if there is no independent process, okay, and there is a circular wait, in that case we have definitely have a deadlock. So it depends actually on you that how you can actually find out. But these are the basic two steps. First, look for independent process and then look for the resource allocation. And here is actually another example that why that there's no deadlock here, but there is a deadlock here. Okay, so you can go through these examples, and then we can actually in the next here you see I have given the graph here, but in the exam you will actually not be given the graph. You will actually be given a question like this. Okay, so here you will be have a P, that is the number of process P1, P2, P3, P4. You'll have given R1, R2, R3, and then you will be given an age. That means R1 to P1. That means R1 is being allocated to P1. P1 to R2. That means P1 is waiting for R2. So after the same example that you have here, okay, is the same one is this one. Okay, so first what you have to do is that from this question you have to draw this graph. Okay, and after drawing this graph, okay, what you have to do, you have to find out whether there is any deadlock or not. Okay, so let me explain one. So let's assume this one. So P, so I want to draw this one. P equals to P1, P2, P3, P4, R equals to R1, R2, R3. So what we will do at first, okay, what we will do, we'll actually first, let's assume we'll draw the process. So let's assume P1, okay, let's take this space, okay, P2, P3, and P4. So we'll first draw 4 circles. And then we have how many resources? We have 3 resources. So we'll draw 3 rectangles. The first one for resource R1, second one for resource R3, 2 and R3. Then we will see that how many instances each resource has. So R1 has 2. So let's use 2 here, 1 and 2. Okay, so let's just use 2 dots here. Then R2 has 1. So let's draw 1 dot here. Okay. And then R3 has 1. So let's draw 1 dot here. So now what is the next task is to assign this arrow. So R1 to P1. So let's assume this is my R1. So I have to actually erase R1 to P1. Then we have P1s to R2. So let's assume this is P1. So P1 is waiting for R2. Okay, so in this way, you will actually have one step by step. After practicing a little bit, you can actually draw the graph. And from the graph, last line, you have to draw a resource allocation graph. For that, you'll have a small part of the mark, and then you can explain the possibility for a deadlock. So after drawing this one, the resource allocation graph, you have to explain whether there is a deadlock here or not. So here is some examples. Okay, practice them at home. And in the next class, I will go for the other topics.